The lesson topic for this video is types of angles in trig, reference angles. In the previous lesson, we learned about angles in standard position as well as coterminal angles. We're going to go back for a second and talk about that idea of an angle in standard position. I'm just going to draw one in this coordinate plane here, remembering that our initial side is, the vertex is on the origin and the initial side is on the positive x-axis. And the terminal side of that angle is, well, somewhere else. So let's say right here. All right, so if that's our angle that we're starting with, we actually have a symbol we use for that original angle, and that is this symbol right here, which is theta. Okay, theta is a Greek letter that we use, and this right here, this angle is theta. Now what a reference angle is, let me use a different color. What a reference angle is, first of all, we're going to call it theta prime. It's the angle that we can use in reference to this angle we call theta. Okay, so how it's created, as it says in the definition here, let's read it. It says the reference angle for theta, our original angle, is the acute angle formed by the terminal side of theta and the x-axis. Okay, so let's remember first of all that acute is an angle that is, let's call it x, is greater than 0 degrees but less than 90. So it's always going to be one of those smaller measured angles. And it is created by using the terminal side, which is the end ray, which is that one right there, the terminal side of our original angle theta, and the x-axis. Again, here's our x-axis, and when we are creating this angle, we're always going to find what I like to call the closest portion of the x-axis. So yep, this is the x-axis over here, but if we're talking about this terminal side, where's the nearest portion of the x-axis? Well, that's this side over here of the x-axis. So our reference angle in this case is going to be created again by this terminal side of our original angle and the nearest portion of the x-axis, which is right here. This is called theta prime, and that's what I'm going to write over here as well, theta prime. Okay, that little symbol right there tells us the word prime is going to be used there, theta prime. Okay, so just to kind of go through that again, if we have our original angle here, this purple angle, if you can see the purple there, that's theta. We want an angle that we can use in reference to that angle, and we use the terminal side of it, and we go to the nearest portion of the x-axis, and it is acute because it is less than 90 and greater than 0 degrees, and that is our reference angle. Okay, so let's practice just drawing this original angle theta and then drawing in what we believe theta prime is before we get into talking about the measure of that angle. All right, so draw the angle in standard position and then label the reference angle theta prime. So here's my original angle right here, 135 degrees. This is my angle that we'll call theta. So start with a point on the vertex, a ray on the positive x-axis. We talked about 135 degrees in previous lessons. Let's remind ourselves again, 90, 180, halfway between 90 and 180 is actually 135. So we'll go ahead and use that right there. So that is, right there, theta. And we want to draw theta prime. Now again, this is just like the one on the previous example. We're going to use the terminal side of theta prime, of theta, and then the nearest x-axis, which is right here, and this is theta prime. Put that prime in there, sorry. All right, let's try the second one, a little different than the previous. So 196 degree original angle. We know that this is 90, this is 180, so we have to go about 16 degrees beyond 180. Go ahead and draw that right in this area here. All right, so this whole thing here is theta. So where is theta prime? Again, it is an acute angle, so it's going to be a very small angle between 0 and 90. and it is going to use the terminal side of our original angle. So that's this right here, and the nearest x-axis. Well, the nearest x-axis is right here. The same x-axis as I used actually right here, except for we are going kind of this direction. Now we're down in here. So this is theta prime, our reference angle for theta. Now before we do part C, I actually want to change it. So I hope you didn't jump ahead or anything. I want to actually change it to make it show an example that people make mistakes on a lot. So let's go ahead and change that to a 290-degree original angle. All right, so let's draw that original angle in standard position. So there is our original initial side or ray, and then 290. Well, we know that this is 270 degrees if we went all the way around to here, 270. 290, therefore, is not too far past that. 290 may be right around here, 20 degrees beyond 270. Right about there. So there's our original angle, theta. And now we want to find the reference angle for theta. Well, what a lot of people do is they choose the wrong angle, and that is they choose this angle right here to be theta prime. Because it's the smaller one, you think about it being acute, and you think about we want to go to the closest. Remember I said over here we want to go to the closest portion of the x-axis, so people think this. But remember, this is the y-axis, right? This is the y-axis. We do not create theta prime ever with the y-axis. We always use the x-axis. So here is again our terminal side of our angle, right here. We're going to use that. And then the second ray for this reference angle, theta prime, needs to be the nearest portion of the x-axis, which is right here. So this is theta prime. It's important that you do not choose the angle that's created with a y-axis ever for these reference angles. Okay, so a little repetitive on the directions I notice on the screen, but whatever. Okay, so we're going to draw another angle. We're going to label the reference angle theta prime. There it is. And we're going to then find the measure of theta prime. All right, so we're going to draw a 160-degree angle once again in standard position. After all this practice with this in our notes and in practice in class, these shouldn't be much of a problem at this point. 160 degrees is our original angle right there. We're going to label theta prime. Well, theta prime is the angle created with the terminal side of the original angle. Whoop, I'm going to try that again. Terminal ray of the original angle and the nearest portion of the x-axis. So here is theta prime. All right. And the third thing we want to do is we want to find the measure of the angle theta prime. Okay, we want to find the measure of this. Now we could have all sorts of different rules about if it's in this quadrant, you're going to do this. If it's in that quadrant, you're going to do that. I kind of like to use more of use common sense, I guess, when we are trying to find these. If this right here, our original angle we drew in, theta here, was 160, pardon me, 160, wow, all right, 160 degrees, and then we know that if we took that terminal side further and got all the way to the x-axis, we are now at 180. Well, how far do we have to rotate that ray to get to 180? Would be 20, right? So 20 degrees is the measure of theta prime. And we also know that if we started with our initial side of our original angle and went all the way to this portion of the x-axis over here, we've got 180 degrees, and that made up 160 of it. So again, 180 minus the 160 will give you the 20 degrees remaining. Another way to look at it. Let's try the next one. Draw a 315-degree angle. All right, here is our original initial side. 315 degrees will be right in between 360 and 270. So that is theta. And then our reference angle will go from that terminal side of our original angle to the nearest portion of the x-axis, which is right here. So this is theta prime, our reference angle there, and if theta was 315 degrees, how many degrees, again, same idea here, would I need to continue to rotate this ray to get to 360 degrees? Well, that would be 45. So our original theta, 315, plus an additional 45 degrees is going to get us to the 360 full rotation. 205 degree angle. Original initial side, 205 degrees. Well, we have to go about 25 degrees beyond 180. That's probably a little much if you saw that angle I drew. Here we go. All right. Our reference angle is going to use this terminal side of the original angle, and then we need to go to the nearest x-axis, portion of the x-axis. So that right there is theta prime. Now this one's a little bit different. If you think about how our original angle went like this for theta, theta was 205 degrees. So what we have to kind of think about here is how many degrees, again, we're looking for theta prime, and we need to know how many degrees we went beyond 180 to get to 205. So from 280 to this terminal side was 25 degrees. Okay, so for these last three examples, they are pretty much the same thing as the previous slide. I would like you to pause the video and truly try these on your own and see how you did on them. Pay careful attention to the fact that this last one here is a negative 211 degree original angle. Check back to see how you did. Okay, so hopefully you got 60 degrees, 80 degrees, and 31 degrees for your three reference angles. Remember that theta prime is always positive, so if any of those were negative, not good. And I meant to say they're always acute, so if any of them were more than 90 degrees, that's not what we want either. Remember this last one, when the original angle is negative 211, it travels this direction clockwise up to here. How many degrees would we need to actually get back to our closest portion of our x-axis? And that was 31. So that one was a little trickier maybe for some of you. Let's do more practice in class.